Greetings, math fans. All right, so this is day 3, and what we're going to talk about today is geometric sequences and series. So basically, if I want to define for geometric, it's a sequence in which each term after the first which we call, of course, a sub 1, is obtained by multiplying, that's a key word, right before it was adding, so by multiplying the preceding term by a fixed number, and that's the common ratio, and we call that R. Okay, and before we had our common difference was D, and that was what we added and subtracted, and this is our common ratio R, which is what we multiply. Okay, so let's just kind of start with an example here. If I give you guys 3, 6, 12, 24, 48. All right, well, first of all, you get your common ratio, you take the term after, so it's 6 divided by 3. Okay, so be careful about that, because sometimes kids do 3 divided by 6 and they get 1/2, but as you can even see, it's going 3, 6, 12, it's getting bigger, so our common ratio is 2. Now again, it's always good to check it, right, just to make sure it is a common ratio, so 12 over 6, 2, 24 over 12, 2, etc. Okay, so that's good. Let's kind of develop an equation for this. We know our common ratio is 2. And do you guys agree it's 3 times 2 to the 0 power? That gives us 3, and that's the first term. So it's 3 times 2 to the first power, and that gives us 6. That's the second term. 3 times 2 to the second power, so that's 3 times 4 is 12. That's the third term. 3 times 2 times 2 to the third power, so it's 3 times 8, 24, n is 4. So you guys can see this term right here is what? That's our first term, a sub 1, right? And the value right here, right, that's R. And this value is what? Well, it looks like it's n, but it's actually 1 less than n, isn't it? So when n is 1, that's 0. When n is 2, that's 1. So it's really n minus 1. It's 1 less than that. Okay? So our general formula, no saluting required, is a sub n is equal to a sub 1, the first term, times R, the common ratio, raised to the n minus 1 power. That's it, math fans. That, you need to put some stars around it, some moons, green clovers. That's a bad clover. Whatever that is. Okay. Anyway, you just need to put something around it. That is a really, really important formula, and that is for geometric sequences. Okay. So let's use that nice little friendly formula here. My example is going to find the 10th term of 100, 50, 25. So the first thing you have to do is you have to determine if it's geometric or arithmetic. Okay, it's really important. Well, I mean, what I'm going to do is I can kind of see 50. It's certainly not arithmetic because I'm going down by 50 and then going down by 25, right? It's got to be consistent. So it's definitely, I'm going to try geometric, and do you guys agree? I'll say R is equal to 50 over 100, which is 1/2. Test it again. R equals 25 over 50, which is 1/2. Okay, and that's all we need. So we have a sub 10, right? A sub n equals a sub 1, which is the first term, which is 100, times r, which is 1/2, to the n minus 1. So it's to the 10th term, so it's 10 minus 1. Okay, and you put that in your calculator. So a sub 10 comes out to be, and again, use your fraction button, 25 over 128. Okay, not bad. So let's do a little bit different kind of problem, still using the same formula. But let's say that a sub 3, the third term, equals -2. I'm telling you the common ratio is 4, and I want to find a sub n, so that's the general term, and I want you to find then a sub 5. Once I have a sub n, it's easy. Just plug it in 5 in there and I get it. Okay, so I'm given these two pieces of information. Really what I need here, because think about it, if I want to find a sub n, it's a sub n equals a sub 1 times r to the n minus 1. I really need a sub 1 and I need r. Well, I'm given r, I just need to find a sub 1. So what I'm going to do is I'm going to take this formula and I'm going to kind of plug things in, right? I know a sub n, in this case I know a sub 3 is -2, so it's -2 equals a sub 1, which I'm looking for, times r, and n is 3 for this one, right? To the 3 minus 1. So -2 equals 4 squared, so 16 times a sub 1. Divided by 16, a sub 1 is -1/8. So that's really important to find my general term, because a sub n equals a sub 1, -1/8, times r, which is 4, to the n minus 1. Okay, so that is my first answer here, a sub n. And then, of course, I want to find a sub 5. So you just put a 5 in there for n, so -1/8 times 4 to the 5 minus 1. So a sub 5 is equal to -32. Okay, pretty straightforward. Okay, let's do another example. I got a bunch of these here to do for you. If you're given a sub 4 is 5 and a sub 8 is 1 over 125, I want you to find a sub 1 and r. Okay, so what I really need to do is kind of like I did back in arithmetic. I kind of need to do a temporary because I'm given two a sub n's, if you want to look at it this way. And what I want to do is just make this one a sub 1, so I'm going to basically subtract 3 from that n. So a sub 1 is 5, and then I'll do the same thing, subtract 3, so a sub 5 is 1 over 125. So the spacing is still the same. It's still 4 apart no matter what. So I'm going to find r now with that. So I get a sub n, which is 1 over 125, equals a sub 1 times r to the n minus 1. Well, n is now 5, right? To the 5 minus 1. So I divide by 5, and I get r to the 4th equals 1 over 625. And basically I take the 4th root of that, and remember when it's an even power, math fans, you got to get plus or minus. Okay, plus or minus is huge. You cannot forget that. Kids always forget the plus or minus. They go, oh, it's just positive. It's plus or minus. So when I take the 4th root of 625, it's 5, so it's plus or minus 1/5. Okay, so that's the first part, because I asked you to find r. You got to find that first. Now I want to find a sub 1. Well, I'm kind of going back and using either one of these, this guy or this guy, doesn't matter, to find my a sub 1. Well, I'm going to use a smaller one. It's just a little bit easier, a little bit closer to the a sub 1. So do you guys agree? I'm going to say a sub 4, which is 5, equals a sub 1 times r. Well, I got two values, so I'm going to have two different answers. Positive 1/5 to the n minus 1. Okay, and of course it's to the 4 minus 1, right? So I get 5 equals a sub 1 times 1/5 to the 3rd power. And 1/5, so it's 5 equals a sub 1 and 1 over 125. So a sub 1 is equal to 625. And of course, if I do the same thing, 5 equals a sub 1 times negative 1/5 to the 4 minus 1. It's the exact same thing. I get 5 equals a sub 1 negative 1/5 to the third power. That gives me a negative, so 5 equals a sub 1 times negative 1 over 125. Okay, then I multiply both sides by negative 125 over 1, right? I solve for a sub 1, and I get a sub 1 is equal to negative 625. So two answers. Very important. That plus or minus actually, well, you have two answers for r, and then you have two answers, of course, for a sub 1. Okay, so that's not bad. Different kind of problem here. If I give you, so all kinds of different problems here. A sub 1 is 1/8, and I tell you a sub n is 128 over 243. And I also tell you r is 4/3. So I want you to find n. So basically, I want you to find which term that 128 over 243 is. That's basically what n is, right? So it's pretty easy. Just kind of plug it in. 128 over 243, that's a sub n, equals a sub 1 times r to the n minus 1. Okay, so then I'm going to multiply both sides by 8, and I get, let me put this on this side, so 4/3 to the n minus 1 is equal to 1024 over 243. So what do you do with this? Remember, you take the log of both sides. That allows that to come in front. So you have n minus 1 times log of 4/3 equals log of 1024 over 243. Okay, and just, be careful, right? I'm dividing both sides by log of 4/3. Just watch your parentheses. And you wind up getting n minus 1 equals 5. Now, if you did something wrong, you're not going to get a whole number. In fact, you're not going to get a natural number as a final answer, right? So just be careful about that. And I add 1, and I get n equals 6. And that was kind of our whole goal here. All right? But that, remember, needs to be a natural number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. Can't be a decimal. Can't be negative. It's got to be a positive number, natural number. Okay? Not bad. All right, so let's see. Last example here, and then I'm going to show you one more formula. So bear with me, because these are all important types of problems here. So let's say you're given 4, 12, 36, and 108. And I want you to define the sequence by the nth term, which we call that the general, no saluting required, the general formula, or sometimes called the general term. All right, so first thing you need to know is it's geometric. Okay, if it's geometric, then we set up as geometric. If it's arithmetic, then you set up as an arithmetic. We've done this already, but we know, so I'm going to write, you must know it's geometric. That's huge. So we're going to say r is equal to 12 over 4. So it's 3, and r, just check it out, r is 36 over 12, which is 3, right? We know r is 3. And we know a sub 1 is 4. So our general term is a sub n equals a sub 1, which is 4, times r to the n minus 1. That's it, math fans. That is like so easy. And I want you, this is important, note, okay, put a little star by this guy because you may see this, wink, wink, nudge, nudge, poke, poke. If the same base, so let me move this up here a little bit. If it's the same base, for example, if I have a sub n equals, let's say a sub 1 is 2 and r is 2 to the n minus 1, I don't want you to leave it like that. Think about this. If it's this way, do you guys agree that's really 2 to the first power? And what happens when you multiply with the same base? Don't you add the exponents? So if I add those exponents, I get 2, so then I have 1 plus n minus 1. So a sub n is really equal to 2 to the n power. Okay, so I want this, it's got to be in this form. I'm going to say must be in this form. Okay, very, very important. So please, again, put a couple stars, moons, green clovers, whatever you want around that. It's important. If you have the same base, you need to simplify it. Okay? All right. Last thing here, it's another important formula. This is a geometric series. Okay, and of course, if I define that, you guys already know what a series is. It's the sum of the terms of a geometric sequence. Okay, pretty easy. So here is your general formula. I'm just going to give this one to you. It's S sub n, the sum of n terms, equals a sub 1 minus a sub 1 r to the n power over 1 minus r. Okay, I'm going to put a box around that one. There's a couple stars here. It's a bad star. Okay, again, moons, green clovers, whatever you need to put around here. Very, very important formula. Okay, one thing I want to point out here, so I'm going to highlight this right there, that n is to be careful. It's not n minus 1. Because remember the other formula for geometric sequences is a sub 1 times r to the n minus 1. This is not to the n minus 1. This is to the n power. Very, very important. Okay, so let's do a quick example here. Do it right below it. Given 2 comma negative 1 comma 1/2 comma negative 1/4, find the sum of the first 20 terms. Okay, so basically we have r. Well, I know it's geometric because it's negative 1 over 2, which is negative 1/2. 1/2 over negative 1, which is negative 1/2, right? So I know r is negative 1/2. And what else do I need? I need a sub 1. Well, that's easy. It's given. A sub 1 is 2, right? And n is, I'm finding the sum of the first 20 terms, so n is 20. So I've got everything here, math fans. Okay, it's kind of nice. So it's s sub 20 is equal to a sub 1, 2 minus 2 times negative 1/2 to the 20th power over 1 minus a negative 1/2. Now, what you have to do, math fans, is you got to be careful. Okay, let's move this down here a little bit. I'm going to put a little star here. You got to use so many parentheses here. Okay, so what I would do is this: either use for the top, you use a parenthesis, or you hit equals after you do that. But you got to put that in parentheses. So let me highlight which parentheses. You definitely got to put this in parentheses. That's important because it's got to be. If you don't put negative 1/2 in parentheses and you raise that to the 20th power, it's going to give you. First of all, it's going to give you a negative value. Second of all, it's not. It's just going to do the type negative 1 divided by 2 to the 20th. Actually, this won't mess up that much, but if it's something like 3/4, it's just going to raise the 4 to the 20th power, and you need the whole 3/4 to the 20th. All right. So the top needs to be in parentheses, and of course, oh here, let me put this here. That needs to be in the parentheses, the top, and then of course the bottom. Because if you don't have the bottom, you're going to divide by 1, and then you're going to add 1/2 to the whole thing. All right. So you got to use a lot of parentheses, and if you do that, you get s sub 20 is equal to 1.33. And your calculator won't give you a fraction because it's too complicated of a fraction. But try it on your calculator and you should get 1.33. Okay, so that is it, math fans. That's using, again, geometric sequences, bunch of examples with that, and one example here with geometric series, the sum of so many terms of a geometric sequence. All right, so 2 more equations you got to know. Make sure you memorize them. All right, math fans, that's it. Have an outstanding day. Adios. Goodbye.